Which of the following are functions? If it is not a function, explain why not. So remember, in order to be a function, each input, or each x value, has to have only one output. You have to know exactly what you're going to get if you input something. You'll get the same output every time. So if we look at the first one, let's look at the input of x equals 0. So when x equals 0, that's right here along the y-axis, we have a y value of 4, or right here we have a y value of -1. So this is not a function. It's not a function because x equals 0 has two y values. So in part B, our x value is -3 goes to 19, 5 goes to 19, 19 to 0, 0 to 3. This is a function. Each x value has only one y value. Let's look at this one. When x is 7, we go to 10. -2, 0, 0, 10, 7, 3, 4, 0. Oh, this is a problem. So this is not a function because x equals 7 goes to 10 and goes to 3. So that makes it not a function. This one, it looks like every x value has its own y value. So this graph, it doesn't actually turn into a straight line. It keeps going out forever. This is the graph f of x equals x cubed. And so every x value that we put into here is going to pop out a different y value. So this is a function, yes, because there are no x values with more than one y value. Find the x and y intercepts in the problem above. So for A, the x-intercepts, so where the graph crosses the x-axis, are right here and right here. So that's at -1, 0 and 1, 0. The y-intercepts, let's see, are 0, 4 and 0, -1. For B, the x-intercepts, so remember that's along the x-axis, that's when y equals 0. So right here. So the x-intercept is at 19, 0. The y-intercept is when x equals 0. That's right here. So when x equals 0, we're at 0, -3. For C, our x-intercept, that's when y equals 0. Those are right here, x-intercept, and right here, x-intercept, y equals 0. So -2, 0 and 4, 0. Our y-intercept is when x equals 0, which is right here. And then for D, our x-intercept, when it crosses the x-axis, that's right here and right there. So at -1, 0 and 1, 0. And the y-intercept is right here at 0, -1. I know we haven't really talked about how to find the slope in the y-intercept yet, but this is something that you might remember from last year. So to find the slope, we have to do the rise over the run, or as we like to call it here in algebra, the change in y over the change in x. And we'll talk about what that means. But for line A, the slope, it goes over 1, up 1, over 1, up 1. So it's 1 over 1. The y-intercept, where it crosses the y-axis, that's going to be up here somewhere. So here we're at -2. We go over 1, up 1, we're at -1, and then that's, let's see, it's 11. So now we're at 12. Over 1, we're on the y-axis. Up 1, we're at 13. So the equation, y equals mx plus b, m is the slope, and b is the y-intercept. So in our equation, we have y equals 1x plus 13. For b, our slope goes over 1 and up 1, 2, 3. So rise, we rose 3 and we ran 1, 3 over 1, which equals 3. The y-intercept of b is right here at 0, 10. So our equation is y equals 3x plus 10. For c, our slope runs 2, rises 1. So our slope is 1/2. And then the y-intercept is right there. It's in between 0 and -1, so it's -1/2. So 0, -1/2. So the equation of this line would be y equals 1/2 x minus 1/2. And then for d, our slope goes down 2 over 1, 2, 3, 4, 5. So our rise is -2. Our run is 5. The y-intercept is right here in between 5 and 6, -5 and 6. So the y-intercept will be 0, -5.5. And so that means the equation is y equals -2/5 x minus 5.5. For the word problem below, complete the table and graph, then try to write a function to represent the situation. Alejandro has a job selling baseball programs at the local ballpark. He gets paid $10 per game plus $1 for every program that he sells. So if he sells 0 programs, he still gets paid $10 because he worked the game. And then he gets $1 for every program that he sells. So if he sells 1 program, he gets 11, 2 programs, 12, 13, 14, 15, 16. So if we want to make this equation, the number of programs that he sells is the independent variable. And the amount of money is the dependent variable, because how much he makes depends on how much he sells. And then, oh wait, I made a mistake here. This is 10. So if he sells 10 programs, he gets paid $10 plus the extra 10. So this should be 20. So we're going to go all the way to 10. I'm going to skip by 2's. So we go 1, 2, 3. And then I need to go all the way up to 20 on the y-axis, so I'll go by 1's. So I'll just label it 2, 4, 6, 8, 10, 14, 16, 20. So if he sells 0 programs, he makes $10. 1 program, $11. Oh, that's not right. 1 program, $11. 2 is 12, 3 is 13, and so on. So now we need to write an equation to represent this. So f of x, so the amount of money that he makes, is $10 automatically plus $1 times x for the number of programs that he sells. For the exponential equation below, complete the table and then graph the function. Make sure you scale your graph appropriately. So this should be t, and this should be f of t. It shouldn't really say programs right here. So we have, if t is 0, we need to plug that in. So f of 0 equals 3 times 2 to the 0 power. Anything to the 0 power is 1. So f of 0 equals 3 times 1, which is 3. F of 1 equals 3 times 2 to the first power. So that equals 3 times 2, which is 6. F of 2 is 3 times 2 squared, which is 3 times 4, which is 12. F of 3 is 3 times 3 squared, 3 times 2 squared, which equals 3 times, 2 to the third power. We're plugging in 3 for t, so this should be 3. The exponent should be 3. 2 to the third power is 2, 4 times 2 is 8. And I'm noticing a pattern here. This is multiplying times 2. So this would be 48 and then 96. So on this axis we're going to have t, and on the y-axis we'll have f of t. Again, I'm going to count by just 2. So I have 1, 2, 3, 4, 5. And then the y-axis needs to go all the way up to 96. So I've got 20 spaces here. So I'll count by 5s and I'll get up to 100. So I'll skip 2 boxes and that's 10. 20, 30, 40, 50. So then at 0, we go to 3. So this is 5 right here. Halfway is 5. So 3 would be a little bit below. At 1, we go to 6. So 6 is a little bit above 5. 2 is 12, which is a little bit above 10. 3 is 24, a little bit below 25. 4 is 48, which is a little bit below 50. And then 5 is 96, which is a little bit above 95. So we can tell that this is exponential because it starts off kind of flat here and then it gets really, really steeper.